Welcome to lesson 5. This is regarding factoring the trinomial. So what we're going to do here is we're going to take trinomials of the form ax squared plus bx plus c, and we're going to break them down into two factors that would multiply together. Okay, so this is the form. It's always going to be in this order, and every number has a coefficient, and that's very, very important. So we're going to start off. There are lots and lots of methods to do this. The one that I'm going to use is called bottoms up, and I'll show you why here in just a few moments. Okay. So first thing we're going to do is this expression, x squared minus 7x plus 10. Okay, here's where we're starting. Now what we want to do is we want to find out what two factors we can multiply together that equal this value. So there's a whole bunch of steps, and for those of you who remember having done this in Algebra 1 and Algebra 2, you'll be able to speed through some of these pretty quickly. For those of you who do not remember, I'm going to give you some hints and things to get through these problems. First thing to remember is, whenever you have an x squared here, it needs an a. It needs a value in front. If there's not already a number there, that number is 1. Okay? And that's important because we're going to need to know what a, b, and c are for each problem. That's the first step. So here, a is 1, b is -7, and c is +10. The next thing we're going to do is we are going to make a large x. On the top of this x, we are going to put the product of a and c, or 1 times 10, which is 10. On the bottom of this big x, we're going to put the value of b, which is -7. And what we're looking for is we're looking to fill these two sides with numbers that multiply to +10 and add up to -7. Now, there's a lot of ways of doing this. What I'm going to do, or I'm going to show you, is a way to put it into the calculator. So in your calculator, you're going to go to y equals, okay, you are going to put in y1, the number on top, divided by x, okay. What that does is it creates a bunch of factors in the calculator. And just let me show you really quickly. 10 divided by x. Okay. And the way this is helpful is now we can go down here and 1 times 10, 2 times 5. You're going to ignore anything with a decimal in it. 5 times 2. These are all factors of 10. Okay. So it's going to be a pair like that that goes on either side here. We don't want the decimals, we want the whole numbers. Now this only gives you the factors. What's going to be super helpful for you though is figuring out which one adds up to this last number. So the way you're going to do that is you are going to put on y2 in your calculator the exact same thing we put here, 10 divided by x, and you are going to put plus x at the end. What that does is it adds the first two columns and puts it in the third column for y2, and that's where you're going to look for the value of b. So if I do that, go back to y equals, go down to the second line, I'm going to repeat the first line, and I'm going to put plus x at the end. Okay? Then I'm going to go to my table, and what I'm looking for is on this third column, I want to find -7. Now if you look over here, we have 11, +7, +7, and then all my numbers get bigger. Okay? Which means if I'm looking for -7, it must be in the other direction. So if I look, there is -7. That means that these two values, -2 and -5, are the numbers that I need. Okay? So this becomes -2 and -5. So that's the first part. Now, for this problem, we could technically stop there. However, I'm going to continue going down this road because it's very helpful for later problems if we do the same thing every time. So to use the bottoms up method, what you're going to do is you're going to look at the value of a, in this case 1. You are going to divide each of these numbers by that value. Okay, and it creates a fraction. -2 over 1, -5 over 1. These two fractions are going to be the basis for our two factors. So one of them is -2 over 1. The other one is -5 over 1. These are going to create two factors. Okay, just like we were looking for. Now here's where the bottoms up comes from. You are going to take the number on the bottom of that fraction, you are going to push it to the beginning and put it as a coefficient of x. So 1x. you are going to take the number on the top of that fraction, you are going to put it afterwards. Minus, let me do some black so we can see a little better, minus 2. You're going to do that same thing with the other fraction. 1x minus 5. Now the reason I put the ones in red for this one is because we know from our years and years of practice that if you have a 1 in front of a variable, you don't really need to put it there. It's understood. So really, the simplified version of this would be x minus 2 times x minus 5. These are the factors that create this. Now, what we're going to do to check our answer, the same method we've done before, is we are going to put in y1 our original question, x squared minus 7x plus 10. In our y2, we are going to put what we believe the factors to be. And then we are going to check to see if y1 and y2 in the table are the same. This is the same method that we used for the last couple of days. So, I'm going to plug this in here. We have x squared minus 7x plus 10, and then we have parentheses x minus 2 and parentheses x minus 5. Get those entered, check our table, look to see if y1 and y2 are the same, and they are, which means that this is the correct answer. X minus 2 and x minus 5. Now, we're going to do a bunch more examples. I'm going to go a little bit faster through them because it's going to be not the first time we've seen these things. So, our next example here is going to be x squared minus 5x minus 24. Remember, a is 1, so we are going to use the exact same method. We need to find out what a, b, and c are. In this case, 1, negative 5, and negative 24. We're going to make our big X here. On the top is a times c. That's 1 times negative 24, which is negative 24. On the bottom is b, which is negative 5. We're looking for numbers that multiply to negative 24 and add up to negative 5. So what we're going to do is we are going to put in y1 negative 24 divided by x, and in y2 negative 24 divided by x plus x. And we're looking for numbers that add up to negative 5 in the y2 column. So let's go ahead and do that. Negative 24 divided by x, negative 24 divided by x plus x. Go to my table, looking in the third column for negative 5. If I scroll here, there we go. Negative 5, which means the answer is 3, and negative 8. So I'm going to put 3 on one side, negative 8 on the other. My value of a is 1, so I'm going to divide each of these by 1. This creates my factors. 3 over 1 creates one factor. Negative 8 over 1 creates my other factor. The 1 goes to the beginning, the 3 goes to the end. It's a positive 3 this time, so it's going to be x plus 3, or 1x plus 3. 1 goes to the beginning, minus 8 goes to the end, so this becomes x minus 8. Okay? Now what we can do is we can check the answer again by plugging this into y1 and our original equation, x squared minus 5x minus 24. We'd plug this into y2 to make sure that y1 and y2 are the same in the calculator. So let's go ahead and do that. We have x plus 3 times x minus 8 in 1. We have x squared minus 5x minus 24 in the other. And we're going to check the table. And sure enough, these columns are all identical. Now you'll notice here that I did on y equals, I did the answer first and the original question second. It doesn't matter which one is which. It also doesn't matter if you have the x minus 8 first and the x plus 3, or the x plus 3 first. Those two things don't matter what order they're in, as long as the pluses are in the right place and the minuses are in the right places. Okay, let's go on to another one. Let's take a look at example number 3, which is x squared plus x plus 1. Now remember here, whenever there's no number in front of the x, the number is 1. Okay, so we're going to use our same method, finding a, b, and c, and then attempting to find all of our values. So a times c will go on the top, b will go on the bottom. A for this question is 1, b is 1, and c is 1. Makes things a little easier for us. 1 times 1 gives us 1 on the top, b is 1. So we're looking for numbers that multiply to 1 and add up to 1. Now using the calculator skill again, in y1 we are going to put 1 divided by x. In y2 we are going to put 1 divided by x plus x, and we're going to look for that number in the third column. Okay, so let me clear this. Let's say 1 divided by x. Here we're going to do 1 divided by x plus x, and we are going to look in our table. Now if you scroll around, you'll see that my right hand column doesn't have a 1 in it. Doesn't have one anywhere. You'll notice the right hand column just keeps getting bigger if we go that direction, and if we go the other direction where it's negative, it just keeps getting smaller and smaller. So this has none. Okay, there are no two values that multiply to 1 and add up to 1. So what that means is that this polynomial cannot be factored. If it cannot be factored, it is considered prime, which is a completely legitimate identity. Now, don't go crazy with this, because you're very rarely going to get prime trinomials when the questions are asking you to factor. So this one is an unusual case. It does not factor. Let's move on to some other problems. We're going to talk about larger issues. 15x squared minus 7x minus 4. So you'll notice that we have now, instead of just having a 1 in front of the x squared, we now have a number. The good thing about using the bottoms-up method is that the process does not change. Everything we've done before, we're going to do the same. There's one little extra step, but it's a pretty simple one. So we're going to first list a, b, and c, 15, negative 7, and negative 4. We're going to make our big X, okay? And then on the top is a times c. 15 times negative 4. If you don't have a calculator, I'm going to tell you it is negative 60, okay? On the bottom, we're going to put b, which for this problem is negative 7. Now, negative 60 is a much bigger number, but if we use the same trick that we used on the other ones, the calculator can still help us find the answer. So we're going to say y1 is negative 60 divided by x, y2 is negative 60 divided by x plus x. We are going to look in that third column for a negative 7. So let me scroll up here a bit. Negative 60 divided by x, negative 60 divided by x plus x. It's very, very important that when you do these, that if this number on the top is negative, this number is negative as well. It's crucial. So we're going to go to our table. We are going to look on the right-hand column for a negative 7. I see positive 7. So maybe if I go the other direction, I'm going to see that negative 7 that I want, which in this case gives us negative 12 and positive 5. Those are the two factors I was looking for. Negative 12, positive 5. Now, we are going to take the a value, and we are going to divide each of these by 15. Okay? So it's the same step we did before, just the number's bigger. Here's the additional step. You are going to take these two fractions, negative 12 over 15 and 5 over 15, and before we go plugging those into our parentheses to find our real factors, what you need to do is see if these fractions reduce. They do. Now, if you're not super comfortable with doing it in your head, you can use the calculator, plug them in as the fraction, negative 12 on top, 15 on bottom, and the calculator will tell you what that reduced fraction is. If the reduced fraction is negative, always put the negative sign on top. So this becomes negative 4 over 5. 5 over 15 will do the same thing. 5 over 15 reduces to 1 over 3. So this equals 1 over 3. Now, once you've reduced those fractions, it is the reduced versions that are going to create the two factors. So this 5 goes here, becomes 5x. The negative 4 goes after, which becomes a minus 4. Here, the 3 goes first, becoming a 3x, and the 1 goes second, becoming a plus 1. 5x minus 4 times 3x plus 1 should equal 15x squared minus 7x minus 4. The bigger the numbers, the easier it is to make mistakes. So we always want to make sure that we take our original question, put it into y1, our supposed answer, and put it into y2 to check. So let's go to y equals. There's a lot of calculator tricks here. You don't need the calculator for any of this, but it's going to make it a heck of a lot easier. 15x squared minus 7x minus 4. On the second line, 5x minus 4 times 3x plus 1. We are going to check our tables to see if these two columns are exactly the same. Those numbers are pretty big, but they are the same big numbers if you look across. Okay, let's go on to our next example. Example 5. Running out of room on the paper, so we're going to cram this one in here pretty tight. 6x squared plus 23x plus 20. Same method. Find a, b, and c. We're going to plug in a, b, and c. And then we are going to go ahead and factor this thing. A times c on the top, b on the bottom. 6 times 20 is 120. 23 on the bottom. Oops, let's make that 23. So y1 will be 120 divided by x. y2 will be 120 divided by x plus x. And we're looking for those two factors that will add up. I have to cover this up a bit because I'm running out of space. So 120 divided by x, second line, exactly the same thing with a plus x tagged on the end. Let's go to our table. We are looking for 23. I don't see a 23 yet. But there it is. 8 and 15. Okay, so my two numbers are 8 and 15. Now once I've got those, I go looking for whatever a is. I'm going to divide them by a. Okay, and then I'm going to use those two identities to see if they reduce. Now, in order to save us a little bit of trouble, you can plug these into the calculator as fractions, and if you press enter, the calculator will automatically reduce them for you. But I happen to know, because I'm a math teacher, that 8 over 6 reduces to 4 over 3, and 15 over 6 is going to reduce to 5 over 2. So these are going to create my two factors. Bottoms up, bottom to the front, top to the back. 3x plus 4, bottom to the front, top to the end there, 2x plus 5. Now in the interest of continuing our checking of the answers, we're going to go ahead and plug these things in. I don't have room to rewrite them. We're going to start with the original question, 6x squared plus 23x plus 20. On the second line, we're going to put what we believe the answer to be, 3x plus 4 times 2x plus 5. And we are going to check the tables to make sure that the second two columns are identical. All right, a few more examples and we'll be along on the way. So let's go ahead and take a look at this one with numbers that are a bit more tame. We have 2x squared minus 5x minus 4. Finding a, b, and c is our first step. A is 2, b is negative 5, c is negative 4. Okay, so a times c, 2 times negative 4 is negative 8. Negative 5 is going to go to the bottom. We need numbers that multiply to negative 8. So we're going to say negative 8 divided by x. Then we're going to see which of those numbers adds up to negative 5. Okay. So we're going to plug those into y1 and y2. Negative 8 divided by x on the first line. Negative 8 divided by x plus x on the second. Go to our table. And we're looking for negative 5 in the far right hand column. Now if you notice that it skips over, we go from 4.6 to 5.8. Okay, well let's scroll back up the other direction just to be sure. Nope, skips over it again. That means that this is a prime trinomial, because it cannot be factored. Okay, and you'll find that out at this phase. If you can't find numbers that multiply to the top and add to the bottom, it means that it's going to be prime. Won't see many of those, but it's good to know they're there. Let's go with the next one. 2x squared minus 13x minus 35. You'll notice the numbers get bigger and bigger, but there's no need to be afraid of that. We are going to do the same method, and it works every time. In this question, a is equal to 2, b is equal to negative 13, and c is equal to negative 35. Okay, so we're going to build our large x. On top is a times c, on the bottom is b. 2 times negative 35 is negative 70. You can use your calculators for that if you're not confident with it. And the bottom, negative 13. Okay, so in y1 we are going to put negative 70 divided by x. In the next one we're going to put the same thing plus x to see if we can find negative 13 in that far right hand column. So negative 70 divided by x. Negative 70 divided by x plus x. Look for negative 13 in the far right hand column. I'm not seeing it there. Let's see. It goes from 9 to 13.5. What about the other direction? Let's take a look. Nope. I am not seeing it. Now, if you don't see it, what that means again is that this function is prime. On to our next example, example number 8. We're getting close to the end here. We are starting off with 3x squared minus 25x minus 18. Okay, same method. We're going to start off with A, B, and C. A in this case is 3, B is negative 25, and C is going to be negative 18. So we're going to create a large x, so we can put A times C on the top and B on the bottom. 3 times negative 18 is negative 54. And then on the bottom, negative 25. So we're looking for numbers that multiply to negative 54. So we're going to do negative 54 divided by x. In the second line, same thing, and we're going to add x to that. Okay, so we are going to go into our calculator to see if we can find those numbers. Negative 54 divided by x, and then negative 54 divided by x plus x. We are looking for negative 25. Well, I'm already in the negatives where I am right now. If I keep scrolling a little bit, I found it. Negative 25 is negative 27 and positive 2. Sometimes you have to scroll a little bit, but make sure that you do that till you get to at least the value you're looking for on the y side. So negative 27 and positive 2. Negative 27 and positive 2. Remember to take that value of a, and you're going to divide each of these by that value of a. So I have negative 27 over 3, and on the other hand, I have positive 2 over 3. I want to see if either of these reduces. Sometimes both does, sometimes one does, sometimes neither do. So 2 divided by 3 I know is not going to reduce. Negative 27 over 3 looks like it might do something though, so I'm going to check that one. Negative 27 divided by 3. Oops. Yeah, I put that in wrong, didn't I? Let's try that again. Negative 27 over 3 reduces to negative 9. Now, when you get a whole number, if you're doing this method to check and see if something reduces, just put it over 1. Okay, that's the easiest thing to do there. Negative 9 over 1. Because that way you still have a top and a bottom, and you can still use the bottoms up method. Bottom to the front, top to the end becomes x minus 9. For the other one, bottom to the front, top to the end, 3x plus 2. We are going to again check our answer by plugging in our answer, or the answer we believe it to be, into y2, and the original question into y1 to check the tables. So I'm going to go back to the calculator, and I'm going to check. 3x squared, oops, I need to be in y equals. 3x squared minus 25x minus 18. And then I'm going to say x minus 9 times 3x plus 2. Okay? Those are the two I'm working with. Go to my table. Oops, that was not the table. Getting a little loopy now. Sorry about that. Go to my table, and my two columns should be identical. Well, with numbers that big, it's kind of hard to tell. So if we get back down to where the numbers are smaller and more manageable, you'll still be able to see that the left and the right columns, y1 and y2, are identical all the way down. Okay, so that one does definitely check out. Now we are going to go, we're going to do one more problem, and then we're going to do a little bit of extension with that, because you will have some questions on your homework that ask you to find zeros. So we're going to remind ourselves how to find zeros. This is not a new thing, it's just something that we haven't done on this particular lesson yet. So here's our new function, 6x squared minus 23x plus 20. Okay, finding a, b, and c to be 6, negative 23, and positive 20. We're going to use our large X to find those values. A times C, B on the bottom. 6 times 20 is 120. On the bottom we have negative 23. So we're going to take the 120 divided by X on Y1. On Y2 we're going to do the same thing, and we're going to plus X at the end to look for the numbers to fill in that gap. So here we go. 120 divided by X on the first line, 120 divided by X plus X on the second. In the third column, we are looking for a negative 23, and I guess we just found it. Just happened to be that first one. Negative 8 and negative 15 is negative 23. So negative 8 and negative 15. We are going to take our value of A, divide each of these by that value of A, and then use those numbers to create our two factors. See if they reduce. Okay, negative 8 over 6 reduces to negative 4 over 3. Negative 15 over 6 reduces to negative 5 over 2. So our two factors are going to be created from these two fractions. Bottom to the front, top to the end becomes 3x minus 4. Bottom to the front, top to the end becomes 2x minus 5. We can check our answer again by plugging the first original question into y equals 6x squared minus 23x plus 20 the answer that we believe is correct into the second line. 3x minus 4 times 2x minus 5. 2x minus 5. Check our tables. Okay, our tables are correct. So that's the correct set. Now what we're going to do is we are going to find the zeros. This is not news. Okay, this is something that we've done using the calculator before. So we are going to check the graph. Okay, there are 2 zeros right there. Now, for the sake of making this a little bit easier to see, I'm going to zoom in. Okay, actually I'm going to go ahead and get rid of the second line here. And if you'll notice, it doesn't change because those two things are equal. It actually makes the same graph. So I'm going to zoom in a little bit here so we can see a tiny bit better. I'm going to put it right between there. Okay. Now, if you'll notice, they are at odd places, in between 1 and 2 and between 2 and 3. Now remember, to find zeros, you are going to press second, trace. Okay? When you do that, it brings up the calculate menu. Option 2 is 0. Now, this question has 2 zeros, so we're going to have to do this twice. You're going to see it says left boundary. You're going to move the little blinky cursor to the left-hand side of the first 0 here. You are going to then press enter and move it to the right-hand side, and then you're going to move it close to the 0 as it's listed. So here we have a 0 at 1.333. Now, in order to check and see what this is, as a fraction, if it's a fraction, and look at that, that's definitely a fraction, you are going to press X, math, enter, enter. So one of our zeros is at 4, 3. So X is an element of the set, 4, 3. I know there's another one, so we're going to find the other one. Okay, same steps. Second, trace, 2. Now I'm going to move it a little bit to the left of the second 0, which is this point over here. This is left, so I'm going to press enter now. I'm going to move it to the right hand side, and then I'm going to guess. The reason you do the left and right is because that tells the calculator where to search for the 0. So I'm going to press enter right now, and it tells me 2.5, which is also definitely a fraction. So I'm going to convert that by pressing X, math, enter, enter, and it tells me the second 0 is at 5/2. Now we'll get into more of why this is significant a little bit later, but I do want to point out that these things are very close in nature to these factors. They're very close in nature to these fractions as well. There is definitely a relationship. Okay, if you see it now, great. If not, we're going to go back over this a little bit later on. But for right now, I just want to point out that that's how you do that. We've done this a million times before, but this is one more check. All right? Good luck.